This is the second video of homework 3, question 9. I will follow Professor Chen's clue and explain each diagram according to his explanation. So first, we're going to talk about the diagram 2. It's really simple. There's one pole inside this unit circle and 1, 0. So the HZ could likely be Z over Z minus 0.7 because we don't know the exact position of the pole. So it might be like this. So simply here's the small hn. And this is going to be a monotonically decaying impulse response diagram, so kind of like this. So for diagram 2, we're going to choose R1, and the next one is diagram 8. You can see the poles are outside of the unit circle, so it's going to be unstable, and Hn should be the diverges. So we're going to choose R4 for this diagram. You can see the 4 diverges. Here's the R4, and for the last diagram should be R1. And then for diagram 3, here's 3 poles, and 1 is a real number, and the 2 are complex number, and they're conjugate. So the HZ can be writing this kind of formula, and here we can get a small hn like this. So you can see here's for this one is for the real number, and the first term gonna be a decaying sinusoidal diagram curve, right? And the second one should be second term should be monotonical decay. So combine these two features, we're gonna choose R7. You can see R7 sinusoidal and also decaying for the diagram 3. And for diagram 1, it's kind of like I'm showing this one, but with another pole here and a double 0. So for this diagram 1, we will have a small n like this kind of thing, because here's might be the 0.5 and a minus 0.8. So for the minus 0.8 term, the diagram should be like this, because sometimes it will be positive and sometimes it will be negative. And combine these two diagrams, we can get the 6th response for diagram 1. It looks like this. We have the positive and negative, and decaying, and the positive should be larger than the negative 1. And for diagram 7, we can see here these 2 poles, they will have a really large angle, which is also smaller than 90 degrees. So we can know that the angle is large, the frequency is high, and we assume the WO is pi over 2.5, because pi over 2.2 is 90 degrees. So we assume W0 is this. And then we can get the T equals 5. And according to the response diagrams, only diagram 3, we can get a like T thing is at 5. So we choose R3. And for D4 here, we can see compared to D7, the poles have a relatively small angle, so the frequency is also low. So the same thing to the D7, we assume W0, WO equals pi over 10 and get the T equals 20, and we can choose the R5. It's similar to the D7. And for D5 and D6, they're really, you can see the connection between these two diagrams, so that the poles at D5 seems to have the same angle with as the poles diagram 6. The angles are the same, but the poles in the D5 have smaller regulars. Like you can move the poles here to here. So we will assume they have the same WO as pi over 5, and we get the T equals 10. Also, as R5 is smaller than R6, we can know that 5 decays faster than 6, so we can choose the response diagrams together. The 5 should be R2 and the 6 should be R8. You can say R2 decays faster and R8 will be slower. And this is the conclusion of the answer.